Now, before we start using Gephi, let me tell you about the software tools that we will and won't be using. In this class, we'll be using Gephi for visualization and for calculating simple network metrics. We'll be using NetLogo to understand the dynamics that shape network formation and also to understand processes occurring on networks. And finally, for those of you doing programming assignments, we'll be using iGraph for more sophisticated, more flexible calculations. There are actually a lot of alternatives, and let me tell you about some of them because once you know what capabilities you like, you can readily find them in other software that may be more well suited to your projects. So there's the software package called Pajek, which means spider in Slovenian. It has been developed for a number of years. It's a very mature software package. It has very extensive functionality, which you access through drop-down menus. And the reason why we're not using it, even though I have used it when teaching this type of class in the past, is because it only works on the Windows platform, and some students have had trouble using Windows emulators on other systems. So I've just made the choice to switch over to platform-independent software. However, Pajek might be a very good choice. In addition, there is a book, a textbook called Exploratory Social Network Analysis with Pajek, which guides you through many analyses that you can do with that software. We also will not be using UCINet, which again is fairly mature, or very mature. It has extensive functionality, mostly focused around sociology. So I think until recently, UCINet did not really scale up to large networks. Unfortunately, it's also Windows only, and the license may cost you a couple of $100s if you're not a full-time student or somehow affiliated with a university. We also won't be using NodeXL. NodeXL is a relative newcomer. It's social network analysis neatly integrated into Excel. It's still, I think, very much in beta. It's being developed. However, it's free. And if you are already an Excel user, then this may be a very friendly way to do social network analysis. Again, it's actually Windows only. Only the Windows version of Excel supports NodeXL, and that's why we're not using it. If you're a programmer, there's an excellent alternative called NetworkX. It has extensive functionality, and it's actually built upon Fortran and C libraries, which are optimized to scale for very, very large matrices. And so you can do calculations for very large networks. It's on top of that, it's open source. So that's definitely something to consider if you have this background. There are many, many other alternatives. Most of them are in various phases of development. One very mature package is the social network analysis package for R. It has kind of statistics, heavy-duty functionality. For example, P-star models, which we won't even get into in this course, are supported in this social network analysis package. In addition, if you're interested, so P-star models are used to model networks as they evolve, to test hypotheses about what's driving edge formation. And if you're interested in visualizing networks over time with kind of an integrated P-star model functionality, there's the package Sonia that you can use for this purpose. Now let's get to our main task for this lecture, which is to work with Gephi. So what I'd like you to do is to download Gephi. It's free, it should work on any platform, and install it. Once you've installed it, download the data file dining.gephi from the Coursera folder for this lecture, and we can start to play. Now that you've downloaded Gephi and installed it, we can start to play with this dining.gephi data file. Now I've opened it recently, so it's shown in this helpful welcome screen, but perhaps you don't have that, so you can go to File, Open, and navigate to the directory where you've saved it, and then just double click to open it. And here we're waiting for it to load. And pretty soon it's going to tell us, for example, the number of nodes and edges. It's going to tell us there are 26 nodes and 52 edges. What kind of data is this? Well, this was data gathered in a girls' dormitory back, I think, in the 1940s, where the girls were asked to name their first and second choices for whom they would like to sit with at dinner. So this is the dining table partners data set. You can see a random layout here, and I've done this on purpose to demonstrate how even with such a small network as this one, a random layout can really obscure whatever insights you're trying to see. Now, Gephi helps a little bit, so here we can tell, for example, that this girl is relatively popular because lots of other girls have named her as their first or second choice. Now, if we want to know which girl exactly this is, what we do is we select this little arrow plus question mark. It's actually and brings up an edit window over here. And now when we left click on this node, we find out that this girl's name is Ava, in addition to some other properties. We also may want to know the overall structure, so we can select a layout. And here I went to the layout panel and I'm going to choose a layout. Force Atlas 2 is one of my favorites, but Yinfen Hu is also very fine. It turns out it doesn't matter too much when the network is this small. It's more with large networks that you run into visualization difficulties. So let's try Force Atlas 2, and I'm going to click on Run. There are all of these different parameters which you can tweak and play with that have to do with how the model is running. Essentially, all of these different layout algorithms want to place nodes that are linked close together and ones that are not. It wants them to repel from each other. So we're going to say Run, and it ran. It's doing a little bit of spinning. Let's see if it'll actually spin into a good position. Oh, indeed. Very nice. Okay, let's stop it right there. And you may notice that now some nodes are out of view, so you can click this little magnifying glass that will center it on the graph, but it may end up looking a little bit too small. So I'm going to use the trackpad, or you can use your mouse wheel to just zoom in, and then I'm going to right click and drag and zoom in some more. And this, I think, shows off the layout of the girls' preferences a little bit more clearly. You may want to tweak things just a little bit. I'm going to select the hand to drag the node. Just here it wasn't quite clear who was picking whom, so maybe I'll just move it a little bit. Right, so a little bit of minor adjustment is no big deal. If you're moving things around because you want them to look a certain way to prove some point, then I wouldn't do this. But just for us and wanting to see who exactly has picked whom, I think it's perfectly fine. Okay, some other things that you can do is you can change the color for all the nodes. So if we want them all to be red, and then I right click to choose the color, and then I left click to set them all to red. I may want to, yes, okay, these were a little overlapped, so we just want to avoid overlaps where we don't know whether an edge is incident on the node or if the node is just over the edge and it's actually obscuring it. We can also adjust the size if these seem a little bit big. I'm going to right click on the size. Well, actually 1.0, that's already quite fine. I guess you could try a fraction of the size. Then I'm going to left click, and now they're tiny. So let's go back to 1.0 and set that. Oh, all right. Let's see, 5. Apparently it wasn't 5 before. Okay, there we go. So they were size 5. We may find this more informative if instead of having to click on this edit attribute where we then click on individual nodes and find out, hey, this girl is Hazel and this one is Maxine. This is where I'm seeing on this all this info after I've selected the edit tool. Perhaps if we just show the labels for all the nodes, and so I'm going to click on this T down here that says show node labels. Oof, and they are way too big, so we're just going to try and scale them down a little bit. There we go. And we can go back to the layout and say label adjust. Try to move these around so that the labels don't overlap as much. And it's actually done it. I don't know if you could see it. It happened very quickly. And now all the labels are fairly visible. Another thing that we may want to do is to color the edges differently depending on whether this was a girl's first or second choice. So I'm going to go to the partition tab, click on it. I'm going to click on edges, and I'm going to click this little reload, load the different partitions or actually characteristics of the edges that are discrete categories, and I'm going to click on label. And this has whether it was first choice or second choice, so I'm going to click apply. And now we see all of the second choices in blue and the first choices in red. And I'll stop here because we need to explain some additional concepts before we can use Gephi. Oh, but actually, let me show you. So we're right now in overview mode where we have all these different tools that we can use. We can also click on Data Laboratory. And in Data Laboratory, we have a spreadsheet of all of the node information, and if we click on edges, we have all of the edge information as well. And finally, in preview, we can preview the visualization that then we can export. So I'm going to click refresh now to see it. I should probably see the node label, so I'm going to click that and hit refresh. And then I'm going to unclick curved so that we get the arrows for the directionality of the edge. And perhaps I can also, change the background. In this case, maybe I want a blue background or something like that. Oof, no, not a blue background. Let's go back to white. And then if I wanted to export this, I would click this button down here, and I could choose whether to export it as a PDF or a PNG or an SVG file. I'm not going to do that right now because we have some more work to do. So I'm going to go back to Overview and stop here while we learn a few more concepts, and then we'll be back.